Welcome back, students. In this video we are going to continue our triangles chapter, part 4. In this part we are going to learn about types of triangles. First type of triangles is the scalene triangle. Definition: a scalene triangle has no equal sides. It means it has three sides with different length. Examples: in this figure we have a triangle ABC, and if you notice they placed on the three sides three different codes because the three sides have different length. That's why triangle ABC is a scalene triangle with three acute angles. In this example we have triangle EFG. Also we have three different codes on the three sides, EF, FG, and EG. It means that this is a scalene triangle because it has three sides with different length, and also it has an obtuse angle. So a scalene triangle can have three acute angles or two acute angles, and the third angle can be obtuse. But the three sides should have different length. Also, the three angles have different measure. Second type of triangles, right triangle. Definition: a right triangle has one right angle only. Examples: here we have triangle MNO. We notice that angle MNO is equal to 90 degrees because we have here the code of the right angle. Also, the three sides have different length, but it has only one right angle. The two other angles, NMO and NOM, are two acute angles. Here, when we want to name this right triangle MNO, we must name it MNO as a right triangle at N. We need to name the vertex of the right angle. They need to give us the name of the vertex of the right angle, which here is N. Here it doesn't matter in which order I write the letters in the name of the triangle. N doesn't have to be in the middle. What matters is to mention what is the vertex of the right angle. Here in this figure we have a triangle ABC. Angle ABC of vertex B is a right angle equals to 90 degrees. So this is a right triangle. BAC is a right triangle at B of vertex B. We should name the vertex of the right angle. Now remarks: in a right triangle, the side opposite to the right angle is called hypotenuse. In this triangle MNO, here we have the right angle of vertex N. The side opposite to it facing this right angle is MO. So MO is called hypotenuse. In this right triangle ABC of vertex B, the side facing opposite the right angle is AC. So MO is the hypotenuse of the right triangle MNO, and AC is the side opposite to the right angle in triangle ABC. We also call it hypotenuse. Here the segment AC is the hypotenuse of the right triangle ABC. Now let's look at the two acute angles in this right triangle ABC. Here we have angle ACB equals 37 degrees and the second angle CAB equals 53 degrees. Let's add their measure. 53 degrees plus 37 degrees, it's equal to 90 degrees. So here we notice that the two acute angles in a right triangle have a sum of 90 degrees. This is always the case. Why? Because we already have an angle of 90 degrees, and the sum of the three angles is equal to 180. 180 minus 90 equals 90. So what remains for the two acute angles in a right triangle only is always 90 degrees. And two angles that have a sum of 90 degrees, we call them two complementary angles. So, theorem, the two acute angles in a right triangle are complementary. It means if I add their measure, it will be always 90 degrees. Now, let's continue with the third type of triangles, isosceles triangle. Definition: an isosceles triangle has two equal sides. Example, here we have triangle ACB. In this triangle, we have the two equal sides CA and CB equals 7.4 units each. A unit can be centimeter, meter, it doesn't matter, but they are equal. Important properties: in an isosceles triangle, the two equal sides are called legs. Here we have CA and CB are the two equal sides. We call them legs. So they are equal. We place the same code on these two sides, and we call them legs of this isosceles triangle ACB. CA and CB, these two segments, are the two legs of the isosceles triangle ABC. Second property, the intersection or common point of the two legs is called the main vertex of an isosceles triangle. Here, the two legs CA and CB, they meet at C. C is repeated in both names. It's their point of intersection. We call it the main vertex. Point C is the main vertex of this isosceles triangle. Main vertex. So C is the main vertex of the isosceles triangle ABC. Now the third property, the side opposite to the main vertex, the third side that is not equal to the two legs, is called the base of an isosceles triangle. Here C is the main vertex. The side facing opposite to point C is AB. AB, we call it base. Also, we can tell what is the base of an isosceles triangle by looking at the side that is not equal to the two legs. AB equals 5 units. It's not 7.4. So this third side that is not equal to the two legs, we call it base of an isosceles triangle, and it's opposite to the main vertex. So the segment AB is called base of this isosceles triangle ABC. So also the base is a segment. Now, property number 4, in an isosceles triangle, the two angles at the base are equal. So here, if we notice, the base here is AB. It's a segment of extremities points A and B. The angles of vertices A and B here, if we notice, it means the angles CAB and CBA are both equal to 70 degrees. So they are equal in measure. We call them the angles at the base, or also we call them base angles or angles at the base. And in an isosceles triangle, the base angles, it means the angles of vertices, the extremities of the base, are always equal in measure. In this example, we have angle CAB equals angle ABC or CBA equals 70 degrees. Base angles in the isosceles triangle ABC are equal. Now let's see some examples about these different types of triangles before we continue with the other types. So in this triangle ABC, we notice that CA, CB, and AB, they have different length, 6.5, 5.95. So it's a scalene triangle. And also, if you notice, the three angles have different measure. Now, if one angle is equal to 90 degrees, it's also scalene. If you notice, the three sides have different length. But if one angle is a right angle, we don't call it scalene triangle anymore. We call it a right triangle. Now, if we have two equal sides, let's try to make the two sides equal here. 5.6, 5.6. CA equals CB equals 5.6. These are the legs of this isosceles triangle, since it has two equal sides. And the third side, AB, that is opposite to the main vertex C of this isosceles triangle, we call it base. Now, let's look at this triangle ABC. Here, the two equal sides are BC and BA. So this is an isosceles triangle of main vertex, this time not C, it's B, because the two equal sides are BA and BC. They have B in common. They intersect at B. So B is the main vertex. BA and BC are the two equal legs. Now, the side opposite to the main vertex is AC. So here AC is the base of this isosceles triangle. Now, in this next triangle ABC, after changing the measure of the, after changing its shape, we notice that the sides AB and AC are equal, and they represent the two legs of this isosceles triangle, and the main vertex here, it's point A. AC and AB, they intersect at A. Now, the side opposite to the main vertex A is CB, equals to 8. It has different length than the two legs. CB is the base of this isosceles triangle, and if you notice, the two angles at the base are equal to 37 degrees each. And the angle at the main vertex, of course, it has a different measure. And here, in this isosceles triangle of main vertex B, also the two angles at the base were equal to 31 degrees each. So the two angles at the base in an isosceles triangle are always equal. Here 31 degrees. And in a right triangle, the two acute angles, they always have a sum of 90 degrees, 54 plus 36. So 41 plus 49. They are not equal to 45 degrees each. No, they are not equal. Here they have different measure. But the right angle here, it's always 90 degrees in order to call it a right triangle. Same here. It's a right triangle at A. CB is the hypotenuse, of course. And be careful, if when the three sides have different length, it's a scalene triangle.